Hello everyone. In today's video, we are going to see what DPF is. As the name suggests, DPF stands for Data Processing Framework. The data here means simulation or result data, which could be lying in your result files, your CSV files, your HDF5 files, or VTK files. It could be extended to further more result files. Processing means extraction and manipulation of your result data with various operators which are specific to DPF. It could be a result or mathematical operator which can basically transform your result data that you extracted. It's called a framework because it's kind of a physics agnostic tool where you can basically extract results from various solvers and you can easily plug in this tool into various apps. Okay, without further ado, let's look at how you can extract results using DPF within mechanical. Now, this is done by very simple 3-line of code here. I'm not going into the details of the code here, but just for you to get a flavor of how you can quickly extract results from a result file. As you can see, I start by specifying the import statements, and then I know that the solver file is located in this location. So the file.rst is the solver, is the result file corresponding to this MAPDL solver, and then I just refer that here. And this is the line where I basically extract the result. So I'm extracting a 1 moisture stress at time point 1, and this is the RST path. That's what we saw here. And I'm basically extracting the data out of it. So if I run this code, you can see how I extract the 1 moisture stress for all the nodes in this model. So if you look at this, it's so this is the field container. I'm not getting into the details of what that is, but I'll just extract the field corresponding to the time point 1, and then I say I want to look at the 1 moisture stress for all the nodes, and here you get the list of 1 moisture stress for all the nodes. And then if you count the number of data, it should match with the node count that you have in your model. So it's 621, and that's exactly what we are seeing. And if you would like to look at what this data corresponds to for which node, all you need to do is just look at the scoping IDs for these field, and then you see that 1 moisture stress for node number 19 is your first entity in your result data here. So similarly, if you would like to basically extract any other result, for example, it could be displacement in the X or in the Y direction, for example, just run this piece of code and then you get the displacement in Y direction for all the nodes here quite easily. So get field by time ID, and then I just say 1, and then I say this is the data I want to extract. So I get the displacement in Y direction for all the nodes, and I get the node ID corresponding to that easily by just specifying the scoping IDs here. So you have a list of results which you can extract here. If I quickly show you, so based on the analysis type, for example, if you are solving a transient structure, you can extract the acceleration. If you have beams in your model, you can extract the beam results and so on. So you can extract contact results, contact penetrations, and so on. So all of these is just to show that how you can quickly extract results using DPF from within the mechanical.